Hi guys, I'm here staying at my dad's place over Christmas and this was waiting for me. This is an old Amstrad CPC6128 computer. This is interesting for two reasons. One is because it's based on the Z80 microprocessor and it uses a basic programming language, which is something I haven't played with since I was maybe 10 or 12 years old. So it's got huge nostalgia value for me. The other reason is because my grandfather has a manuscript for a family book that he wrote. It took him about 12 years to author. And I can actually show you the result of that. So this is sort of like our family tree and everything. It includes our history. And all of this was done on this Amstrad computer here. Now, that took a lot of research and a lot of his time. The issue that we've got now is that he saved everything to these old proprietary 3-inch floppy disks. Now these aren't compatible with any modern computer. It's hard enough to get a computer with a disk drive at all, but these ones are particularly difficult. They're only for these Amstrad or very old computers. So I need to figure out how I can get that data off of these disks and backed up onto a modern computer before we lose it all. So I'm going to do that in the second video, which will come after this one. In this video, I want to concentrate on the computer itself, the technology. We'll tear it apart, we'll have a look at what's inside and how it all runs. And I'll also show you some of the old basic programming language and how we used to program back in the day. The other things I've got with this is an old printer. And I've also got a RS-232 expansion, which I picked up recently. But we'll look at this more in video 2. So this 6128 is the third in the CPC series. CPC is color personal computer. Unfortunately, this is the cheaper model with the green monitor, so it's just monochrome. I am looking for a color monitor to go with this, or another option to get an adapter for an LCD screen or something or other. But today we'll deal with just the monochrome monitor. So there was two preceding this model. There was the CPC464, which was 64 kilobytes of RAM, and it had a cassette tape deck in it instead of a disk drive. So like an audio cassette it used to use. And that was released in 1984. Then they released the 664, which also had 64 kilobytes of RAM, but that was the one that first came out with an inbuilt disk drive like this one, taking these 3-inch floppies. And that was released in May of 1985. And then finally, a few months later, they released this version, which is the 6128. So the biggest difference with that is 128 kilobytes of RAM. They also changed the keyboard and a few other bits and pieces, but that's essentially the change there. So when this was released in August of 1985, they sold for $700 US with the green screen, which is about $1,570 US in today's money. If you spec'd up the color monitor, it was an extra $100. So they sold them for $800 US. And today's money, that's $1,790 US. So that's about the price point. So you can see there's 3 cables that connect the monitor to the main unit here. There's 12 volts here, and in the older models that just had the audio cassette deck, they only needed 5 volts, so this wasn't there. They just needed the 2 cables. With a disk drive, they required 12 volts, so they've added this here, and the 12 volts is sourced from the monitor itself. So this plugs in and powers the 12 volts in the main unit here. The other thing we've got here is a 5 volt supply and the actual video itself. And this video plug is your typical RGB, your sync, ground, and a few other signals like that. It's quite typical of the day. And then I'll just flip this over so we can have a look at the other expansions. Actually, I'll unplug all of this. So here's the main unit. If I flip that over, they've got this sticker on the bottom here, so you can see there's a serial number. Looks like 5 volt DC, 1.7 amp, 12 volt DC, 0.4 amp. There's the disk drive at the front there with the eject button. On the side, there's just a couple of screws. On this side, there's a audio stereo output, a joystick, which is like a D sub 9 connector, and there's a tape port as well, so you could still use the cassette tapes on this unit. And on the back, we've got a printer port. You can see just like a card edge connector. There's the expansion port, and this is where the 232 module will plug into. There's a 12 volt, 5 volt monitor video out. There's a disk drive 2 port, so you can have a second disk drive. There's a power switch and a volume knob. And you can see there's a speaker just behind this grill here. So that's all the bits on there. So we can take this thing apart now. I'll unscrew it. I have to basically flip it over, and there's a number of screws here, and they're all slightly different lengths and different types, so I just need to be careful that I remember where each screw goes. And then once I've got all those screws out, we'll come back and I'll go through the PCB with you and have a look at what we've got there. Okay, so I've got all the screws out. And I should be able to just lift that up, and we've actually got a ribbon connecting this side, so I'm just going to slide this along here. You see there's a couple of flat flex cables, ribbon cables in the middle here, so I'm not going to disconnect them. This is the back of the keyboard here, so you can see we've got the keyboard and we've got the little speaker and a little power LED. So over here we've got the disk drive, and then the volume knob, power switch. It's a little bit dusty, but I'll quickly run through some of the parts in here. So I've read off some of these part numbers and done a bit of Googling, and I think I know where most of the action is happening. So straight off up here is our Z80 processor. This is the main microprocessor for the computer. This is what's doing all the running, the logic, the CPU if you like. And down here we've got two Amstrad branded chips. So this one here is a 16K ROM, and it's got AMS-DOS and the disk drive interface and everything. So this is like the DOS, the disk operating system that runs on this computer. This is a 32K ROM, and this has got the BIOS and the BASIC that runs here, so the BASIC interpreter and everything. We'll go through some software in a bit, but these basically are the two chips that it boots up with. And then for everything else, for actual programs and software and everything, you got to load them in from the disk. Then if we move over here, we've got a sound generator chip, and the Amstrad CPC series was known for having very good support for sound and graphics with the basic version that they used, which was like a Locomotive BASIC, I think they called it. So there's a chip doing the stereo sound, and then we've got a couple of single inline ICs here, and we've got this one's like an op-amp IC, dual op-amp, and this one's a power amplifier for 0.5 watt. So that'll be driving the little speaker and the audio jack and everything. Then if we move down here, we've got some programmable peripheral interface. That's what this chip is doing, and a non-VGA video controller here. So I'm assuming that this one here is to do with the keyboard and maybe the joystick inputs and things. We've got some logic in here, some 7.4 series logic, just some MUX chips and things. And this one here is to do with the video generation. And then also to do with video is this chip here, which is the video gate array. And this, I believe this is what actually generates the RGB signals and the synchronization signals and everything that drives the monitor. So I think it's between these two chips. That's where the video comes in. In the middle here, you see this massive array of ICs. So this is the RAM, and each one of these chips is 64 kilobits each, I believe. So there's 16 of them, and if you do the math, it's 128 kilobytes of RAM. So that's where the 6128, 128 kilobytes of RAM, that's where that comes in. Over here we've got a data separator for a floppy disk drive, so that's doing some logic for that. And then the big chip up here is a floppy disk drive controller. And then again, there's some logic chips and bits and pieces in there. And some of that would be to drive the motors and bits and pieces. But this particularly, I think, is to separate your data signals into something that's able to be written and read to the floppy disk drive. And that's basically it. So obviously we've got an expansion port here and other little logic chips and stuff like that. But and here's the other second floppy disk drive up here. But it's quite basic. The Z80 processor in here obviously is a Ziglag brand, and that runs at 4 megahertz. So we're talking pretty primitive computing. But back in the day, my dad actually built from a kit a Super 80 computer, which is a Z80 computer made by a local Australian company, Dick Smith Electronics. And that used the audio cassettes to save and load programs, and had a green monitor as well. And that's where I started playing around with computers, because Dad basically handed that to my brother and myself, and we went through these old basic programming books, and you could type out basic programs and save them to cassette tapes and program like that. So for me, this hardware is where it all began, and yeah, it's got some pretty decent nostalgia value for me. So that's what we're looking at. What I'm going to do now is put it all back together. I don't want to take it further apart from this, because this is, I might give it a little bit of a cleanup, but I don't want to damage this or risk any sort of faults or issues with this computer, because like I said, I got to get that critical data off of this thing in the next video, and this is the only one I've got, so I'm just treating it very nicely. So I'll put it back together and then we'll fire it up. All right, so let's turn on the computer here, and immediately it boots into the basic prompt. So this is Locomotive BASIC 1.1 if you want to Google that. There's different flavors of BASIC with different capabilities, graphics and sound wise, and things like that. But this is a good all-rounder actually. This is a pretty good BASIC interpreter. So this prompt here is basically ready for us to type in directly. This here, by the way, is being loaded from the ROM chips that I showed earlier. So there was those two ROM chips, the 16K and the 32K. That's all of this here. So we're not doing any disk at the moment, because when you boot up one of these computers, you get your programming prompt and you either type a program in right now into memory and run it, or you load it off of a disk. So you grab one of your diskettes, you chuck that in the drive, and then you can load from the disk into memory and then execute it. Just to give you a quick example, I'll do the classical hello world for BASIC here. So if I go line 10, it's good practice to use line numbers. And you go 10, 20 instead of 1, 2. So if you need to, you can sort of insert extra lines of code in future. I'll just put caps lock on, CLS. So this is clear screen, 20. Print, and print means you're going to print the following characters to the screen in parentheses. So I'll say hello YouTube. Then what we're going to do is go line 30, we're going to do a go to statement, go to line 20. So we're going to keep repeating this print statement. So we should get like a stream of this message printing out. Go to 20, and then 40, we can end, just for good practice to put an end command in there. There we go. So we've now loaded, that program is now in memory. I could clear the screen manually myself right now, and I could say list, and it prints out our program that we've just typed in. And now I can just run that. There it is. That's the classic hello world, or hello YouTube in this case. And to break that, I hit escape. It'll pause it and I hit escape again, and we break out of that loop. And that's like a really simple example of the basic programming language. So now what I'm going to do is I'm going to put a disk in. I've got this disk here, which has a couple of little examples that I wanted to quickly show you. So I'm going to type in cat, which is a catalog command. We're going to have a look at what's on this disk. And there it is. So we've got 3 files on the disk. You can see we've got 175 kilobytes free. Each of these files is only a kilobyte in disk usage. 3D plot, NFM ASCII, NFM sim. So I'll show you NFM ASCII. So to load a program from the disk into memory, we can use the load command. We could also just run it directly off the disk, but I'll load it first so I can show you the code before we execute. Bas, that's now reading the disk. Okay, now if I type in list, this program that we've loaded is now overridden our previous program. You can see that there. Let me just change. The screen mode at the moment is 40 characters wide, so I'm just going to change the screen mode to 80 characters, which will stop with this weird line breaking. It'll make it a bit easier for us to see, so we'll do that. We'll do another list. Okay, so now we can see this program. So you can see we're clearing screen, print, which basically is multiple line feeds. Welcome to the NFM. You see some ASCII art there. These tabs basically mean print. Tab means to tabulate that many characters in from the left. and then we end there at the bottom there. So if I run this, let's go back to mode 1, so it's nice and big, and then I go run. There you go. So that's a cute little basic program, quite simple. Now, another thing I did last night is I thought, oh, I wonder if I can easily get our NFM logo on the screen. Now, there's a number of ways to do this, and I could have done the proper drawing commands where I sort of plot a polygon around and make our logo, which is that hexagonal shape with NFM in the middle. But I found another way to do it, which is a bit of a cheap way to do it. I'll show you that now. So what I did is I made our logo on some graph paper, and I remember back in the day when I was a kid playing with BASIC and doing simple graphics, graph paper was always there next to us on the desk. And what I've done is I've made an 8x8 little grids here, and there's 9 squares there. And by drawing in the logo, I can plot this as a character. So with ASCII, it's like the first 127 characters are like the standard ASCII set, and then beyond that you got extended ASCII. And what I can do is I can replace extended ASCII, or any ASCII characters really, with my own custom characters. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 characters that I'm going to put into this computer, and it's called a symbol in BASIC. So let's load that up. If I go load, so this is a NFM sim.bas program. So we're going to override this one again. Okay, ready. Now if I go list, okay, it's line breaking again. So let me just change the screen mode to screen mode 2, 80 characters, we'll list again. All right. So this program's quite short again. You can see we've got the standard print commands. Now I've got all these symbol commands, and you can see symbol 240 and then these 8 numbers. And what that is I'm overriding the symbol 240 in the ASCII table. And then the first line is 0, 0, 0. You see it's like these are all zeros. If you imagine this is binary, 0, 0, 0. And then we come to line 5 and it's 3. You got 1 and 2 together, that's 3. And then we've got 15, we've got 1, 2, 4, 8, all together is 15. So you can see how I've converted each of these lines into like a byte actually. And I've just written them out here in decimal format. And I've done that for all of these custom characters. So we've defined our 9 custom characters, then I print them. Print 32 as a space, then 240, 241, 242. So our first 3 symbols all together, and then do the same for the rest. And then I wrote some extra text down here. So let's run this and see what it looks like. I'll go back to 40 character width, just so it's a little bit bigger. Whoops, that's mode 1. All right, so let's run that. There you go. And you can see that I've effectively made our little logo up there just by rewriting the ASCII table. So it's a little bit of a cheat way, but I thought that was pretty nifty. Now I want to show you a program that I hadn't done for a long time, and this is one when my dad let us use his Z80 computer back in the day. He had a book called Basic Computer Games, and it was edited by a guy called David H. Owl. So I'll put a link to it down below because it's essentially abandonware now. And the book has been scanned in, and what we used to do is we had this book, it's like 101 programs, and you would open the book to the game or the program that you wanted to run, and you'd literally type in, copying off the page of the book into the computer, and then you'd run it, and you'd see the result, and then you could save it to a cassette tape, or in our case here we can save it to one of these diskettes. So I did that last night, and I want to show you this program. So let me just load that. Load. This one's called 3D plot. Again, it's on the same disk. .bas. Read that off the disk. All right, so let's list this program. All right, let's just go in mode 2 again. Mode 2, list. Okay, so it's a very short program. You see it's got a bunch of math in here, and it's interesting because it's a very concise program, but it does some pretty nifty plotting of 3D objects. So you can see we've got a for loop in BASIC. Looks like this: for x from -30 to 30, and in stepping increments of 2. So we're going -30, -28, -26, all the way through. And then if you come down here, we go next X. So imagine in a more modern language, this here, you might have your curly braces. That's your for loop there. And then inside of that, we've got a nested loop for Y. And here it is. And then next Y. So you've got a loop nested inside another loop. So we've got a two-dimensional nested looping here. And then it's basically calculating off of this def formula up here. This is our formula that defines the 3D object that we're going to plot. And it will decide whether to print an asterisk character or not. So let's run this thing now. Run. And you notice I had some square root math and some multiplication and some other arithmetic. So this poor Z80 running at 4 megahertz, it's a little bit slow, but we're getting there. And you can see what it's doing here. It's plotting like a sphere, or like it looks like the side of the Death Star or something. And it's just doing that using the asterisk key. But it's these sort of programs that were really interesting for me as a kid as well. Like, you know, doing this sort of geometry and math and things like that. And this is a very primitive program. I mean, this computer would be capable of doing this graphically, I imagine. You could sort of plot it with ellipses or polygons and lines and things. But it's just an interesting program. So that's a quick look at the basic programming language and loading from disk. And by the way, if I wanted to save that from disk, I'll just do catalog again. And we can see we've got 3 files. So let's just say I want to save it 3D plot 2, for example. I can literally, because we've got this program in our memory already, as you can see there, I can list it. If I want to save that, save, parentheses, and I'll just say, let's call it 3D plot 2.bas, and hit enter. And that's going to write to disk. There it goes, and I can catalog that disk again. And you can see there, now we've got 3D plot 2. So you can see how you can load and save, and if I want to copy that to another disk, I just pop the disk out, stick another one in, do the save command again, and that's it. So I think that's pretty good for this video. I've got a few other disks here. I've got like a 3D chess and a little flight sim and things. If there's interest, I'll show some of those in another video. But the next video coming up, we're going to try and get 232 comms working on this old computer and see if we can transfer files like this, or more importantly, the files for my grandfather's book, off of this computer into a modern laptop. So check that one out coming soon. And thanks again, guys. See you on another video. Cheers.